Hello everyone, I am Anushka. Today I am solving my assignment question of subject Introduction to Data Science, and this is a part 1 video, and I am solved the question number 1 to question number 5 in this video. So let's start. So the question number 1 is explain the difference between supervised and unsupervised learning, provide example of algorithm for each type of learning and discuss scenarios where each would be appropriately used. So the first one is supervised learning. Supervised learning is a type of machine learning where we train models using labeled data. Labeled means that each example of dataset is already has the correct answer. The model learns that the relationship between input and output and the later use this learning to predict answer for new data. It is just like studying with example to solve examples in textbook because we already know the right answer during training. On the other hand, unsupervised learning work with data that has no labels. The model is not told what output should be. It tries to understand the structure of the data by itself. This type of learning is mainly used for grouping, pattern detection, and understanding the hidden structure within the data. It is like exploring a new topic without any guidance and training to find patterns on your own. Examples of algorithm. First, supervised learning algorithms. First one is linear regression, used for predicting continuous value like house price or temperature. Second one is logistic regression, used for binary classification problems such as spam detection. Now, third one is decision tree, used for both classification and regression task. Fourth one is support vector machine SVM, used for separating data into classes using a hyperplane. Fifth one is K nearest neighbor, KNN, classifies data on the closest training example, and it is also called lazy learning algorithm. Sixth one is a priori algorithm, used for finding association and frequent item sets in transactional data. Example of unsupervised learning algorithms. First one is k-mean clustering. Groups data into specified number of cluster based on the simplicity. Second one is hierarchical cluster, build a tree-like structure to represent data grouping. Third one is principal component analysis, PCA, used for reducing data dimensions while retaining important features. Appropriate use scenarios. Supervised learning is best used when first, you have labeled data input and desired output. Second, you want to predict or classify future outcomes. Example like predicting student grades based on study hours, identifying whether an email is spam or not, or detecting diseases from medical images. For unsupervised learning is best when the data is unlabeled and unstructured. Second, you want to discover pattern or grouping in the data. For example, customer segmentations based on buying habits, grouping similar news articles or products, detecting unusual pattern in network traffic and anomaly detection. Next, question number 2. Describe the concept of hypothesis space in machine learning. Explain the algorithm. Find S. Find the hypothesis by find S for the following instance in the training set. Here you can see the table which has 6 columns: origin, manufacturer, color, decade, type, and class. So the concept of hypothesis space in machine learning, a hypothesis is a possible explanation or a function that maps into attribute to the output label. The hypothesis space H is the set of all possible hypotheses that the learning algorithm can choose from. So, for example, if we are trying to predict whether a car is positive or negative based on an attribute such as origin, color, or type, etc., then each possible rules or the combination of these attributes form one hypothesis. The goal of the learning algorithm is to find the most suitable hypothesis for the space that correctly classify the given training examples. Now, find S algorithm. The find S algorithm is a simple concept learning algorithm used to find the most specific hypothesis that fits all possible or positive examples in the training data. It assumes that all instances are noise free and that there exists at the least one positive example. Steps of find S algorithm. Step number 1, initialize the most specific hypothesis as to the most specific value possible. Step number 2, for each positive training example, compare the example with the current hypothesis. If the hypothesis does not cover the examples, generalize it just enough to include the example. Step number 3, ignore negative examples. They are only used to ensure that hypotheses remain consistent. Step number 4, continue until all examples are proceeds. Now, step-by-step application of find S. Initial hypothesis. Initial hypothesis has all the values set to be find. So the first positive example is Japan, Honda, Blue, 1980, and economy. And the second example is negative, so we ignore it. The third positive example is Japan, Toyota, Blue, 1990, and economy. Compare with the first positive example, and the difference is found that manufacturer and the decades are different, generalizing different attributes to question mark. So you can see the new hypothesis will be Japan, question mark, Blue, question mark, and economy. Now, fourth example is also negative, so we ignore it. Now, the fifth positive example is Japan, Honda, white, 1980, and economy. Compare with the H, Japan, question mark, blue, question mark, economy. We can see the difference in color, that is blue, and other is white. So, generalizing the color to question mark. The final hypothesis will be Japan, question mark, economy. So, the final hypothesis suggested that if the car is from Japan and its type is economy, it will be classified as positive regardless of manufacture, color, or decade. So, now move to the next question. Question number 3. Explain the purpose of training, test, and validation set in machine learning. What is cross validation and how does it differ from the simple train validation test split? So, in machine learning, the available dataset is usually divided into three parts. First is training set, validation set, and test set. Each of these has specific role in building and evaluating a model. First one is training set. This is a portion of the data used to train the model. The algorithm learns pattern, relationship, and structure from the test data. Example, if we are training a model to predict house price, the training data helps the model understand how features like size, location, or age affect the price. Second one is validation set. The validation set is used to tune models parameter and check how well the model perform the unseen data during training. It helps in model selection and hyperparameter tuning and avoid overfitting. The model is not directly trained on this set, but it performs on its helps to adjust setting for better accuracy. Third one is test set. The test set is used after training and validations are completed. It provides an unbiased evaluation of the model's final performance. The test simulation how the model would perform in the real world scenarios on new data. Cross validation is more reliable technique used to evaluate the performance of machine learning model, especially when the data set is small. In this method, the data is divided into k subsets folds. The method is trained on k1 fold and test on the remaining one fold. This process is repeated k times and each fold get to be the best test set once the final performance is calculated by taking the average accuracy of all the folds. For example, in 5 folds cross validations, the dataset splits into 5 parts. The model is trained 5 times, each times using 4 parts for the training and 1 part for testing. Now, the difference between cross validation and train validation test split. In the train validation test split, the dataset is divided only once into 3 parts, one for training the model, one for validating it, and one for testing it. The model is trained a single time using the training set. Its parameters are tuned using the validation test, and it finally accuracy is checked on the test set. This method is simple and fast, but may not always give reliable results. If the dataset is small, since the model's performance can depend on how the data was divided. In cross validation, on the other hand, the data is divided into multiple small parts called fold. The model is trained and tested several times, each time using different fold for training and testing. The average of all these test result gives a more accurate and dependable estimate of the model's performance. Although the cross validation take more time, it help in reducing bias and give a better idea of how the model will perform on the unseen data. Now move to the next question. Question number 4. Confusion metrics find classification accuracy, precision, recall, type 1 error, type 2 error, F1 score, sensitivity, specificity. Explain the importance of precision, recall as compared to accuracy with an example. Here is a table you can see, and is the true positive TP is 6 and false negative is 4, false positive is 2, and true negative is 8. Now classification accuracy. To calculate the accuracy, TP plus TN upon में TP plus TN plus FN plus FP. So 6 plus 8 divided by 6 plus 8 plus 2 plus 4 equals to 14, which is divided by 20. The answer will be 0.7. So the accuracy will be 70%. Precision, for precision, TP divided by TP plus FP. So 6 divided by 6 plus 2, which is 6 by 8. And the answer is 0.75. So the precision will be 75%. For recall, sensitivity and true positive rate, we can calculate recall by TP upon TP plus Fn, and the answer will be 0.6, so the recall is 60%. And type 1 error result will be 0.2, so the type 1 error is 20%. Type 2 error will be 40%, and F1 score is 0.67, so the F1 score is 67%. For sensitivity, and the recalls are same, so sensitivity is equals to 60%, and specificity equals to Tn upon Tn plus Fp, so the answer is 0.8, so specificity is equals to 80%. Now, the importance of precision and recall compared to accuracy. Accuracy alone can be misleading, especially when the dataset is imbalanced, that is, when one class has far more samples than the other. Precision tells how many of the predicted positive are actually correct. It is important in case where false positive are costly. Example, in email spam detection, a high precision ensure that important mails are not wrongly marked as spam. Recall tells how many of the actual positives are correct identified. It is important when missing a positive case has a serious sequence. Example, in disease diagnosis, high recall ensure that most sick patients are correctly identified. Thus, precision and recall together provide a better understanding of model's real performance than accuracy alone. Now, Move to the next question, question number 5. Discuss the importance of dimensionality reduction in the machine learning, compare and contrast features extraction and feature selection as to approach of dimensionality reduction, and provide an example of technique used for each approach. Importance of dimensionality reduction. In machine learning, dimensionality reduction refers to the process of reducing the number of input variable or features in the dataset while retaining the most important information. As dataset grow larger or more complex, they often contain many redundant or irrelevant features. These unnecessary features can make model more complicated, increase training time, and sometimes even reduce accuracy. A problem, know that the curse of dimensionality. Dimensionality reduction helps in improving model performance. Second, reducing computation time. Third, enhancing validation visualization, preventing overfitting, and saving storage space. Now, there are two main approaches of dimensionality reduction. First one is feature selection and second one is feature extraction. Feature selection means choosing a subset of original features that are most relevant to the reduction task. It does not change the data itself, only removes the less important and redundant features. Common techniques: filter method, wrapper method, embed method. Examples in dataset prediction are price, features like lost size and number of rooms may be selected while house color may be removed. In feature extraction, transform the existing features into the new set of features that captures the most important information from the original data. Unlike feature selection, it creates new feature by combining and transforming existing one. Common techniques is PCA, principal component analysis, convert a correlated features into a small number of uncorrelated principal component. Second one is linear discrimination analysis, LDA, and autoencoders, neural network that compresses data into a low dimensional representation. For example, in image recognition, PCA can reduce thousands of pixel value into a few principal components that still capture the main image pattern. Now, comparison between feature extraction and feature selection. Both feature extraction and feature selections are techniques used for dimensionality reduction in machine learning, but they work in different ways. Like feature selections means choosing only one most important and relevant features for the existing dataset. It removes unnecessary and less useful data while keeping the original features unchanged. This helps in reducing noise and improving model performance without altering the meaning of data. For example, methods like chi-square test, information gain, and recursive function elimination is used of feature selection. On the other hand, feature extractions create a new feature by transforming or combining the existing ones. Instead of just selecting, it change the data into the new from the fewer dimension but still retain most of the important information. This approach is more complex but can capture hidden patterns in data. Example including principal component analysis (PCA) and linear discriminant analysis (LDA). In short, feature selection some of the original features, while feature extractions build new one from the old features. Both help in reducing dimensionality, speed up model training, and improve accuracy. Thanks for watching.